Hello and welcome to another Algebra 1 tutorial video. Today we'll be covering lesson 1.3 extension in the Big Ideas Algebra 1 textbook, which is absolute value equations. Before we begin, let's go ahead and look at our objective for today's lesson, which is to solve equations involving absolute value, such as this one right here. We have absolute value x minus 7 equals 9. Now, solving absolute value equations actually isn't any different from solving a standard simple equation or multi-step equation as we've learned in the previous lesson. There are just a few more considerations that you're going to have to make when stating your solution. However, you're still going to use inverse operations to solve. So take this one, for example. Let's just go ahead and break it down into a standard simple equation. So write it as is without the absolute value. So you have x minus 7 equals 9. I'll go ahead and isolate our variable by doing inverse operations. So add 7 to both sides. 7 cancels, and then you're left with x equals to 16. Now, whenever you see an absolute value equation, always remember that it can have more than one solution. So this is a question I pose to you. Is there any other value for x that makes the equation true? There is one more value that will make the equation true, and that would be negative 16. Now, absolute value equations will always have two different values for their solutions. I'll go ahead and explain why on the next slide. So let's just say we have a simple equation like this asking us to solve for y. It just has y within the absolute values set to 8. Now, an absolute value will make any value that isn't contained inside it positive. So when solving an absolute value equation, you must have both a positive and negative solution. So if you were to plug in a positive number within an absolute value, it would still come out positive. And if you were to plug in a negative number, it would come out positive too. So whenever you're trying to solve an equation that involves absolute value, go ahead and include both the positive and negative value because it does not affect the answer as long as the solution is positive. So in this case, your answer will be y equals 8 and y equals to negative 8. So essentially, just always remember to include both the positive and negative solution when stating your answer. We also denote it as this. So if you don't want to write out the answer as y equals 8 and y equals negative 8, then you can just do this plus and minus sign stacked on to one another and then your value. Okay, let's go ahead and look at this example. We're given absolute value x plus 4 equals 9. We're going to first isolate x through solving like a standard equation. So recall that a standard equation would just look like this without the absolute value. So we're going to go ahead and carry out our inverse operations first by subtracting 4 from both sides. That gives us absolute value x equals to 5. We can see here now that the absolute value of x is isolated. So now we can go ahead and state our solutions, which would be both the positive and negative version of whatever solution that we've been given. So we're given here positive 5. So our x will equal to 5 or x equals to negative 5. You can also denote it as this once again if you do not want to write it out. So to solve equations involving absolute value, there are two steps. Solve first for absolute value x using the usual steps. So in the case of this equation, 3 times absolute value x minus 5 equals 10. First, undo subtraction or addition, as you might recall in our multi-step equation video. So I'll go ahead and add 5 to both sides. 5 cancels, and you're left with 3 times absolute value x equals 15. Now that we've simplified our equation to this, we can go ahead and divide both sides by 3 to isolate our variable. and that gives us absolute value x equals to 5. Now that we have isolated our absolute value x, we can go ahead and write our solution as the positive number and its opposite, which is just the positive and negative number. So our x value would equal to positive and negative 5. Okay, let's go ahead and look at this example. We're given 2 times absolute value y plus 1 equals 15. So we'll go ahead and first undo any addition or subtraction. So subtract 1 from both sides. You're left with 2 times absolute value y equals to 14. Now divide both sides by 2 to isolate your absolute value y. And that gives you absolute value y equals to 7. And now that you have your absolute value variable isolated, go ahead and state the positive and negative value of the solution, which would be y equals 7 or y equals to negative 7. Once again, you can denote it as this too. Let's go ahead and look at another example. 3 absolute value y minus 5 equals to 1. Solve it as a standard equation. So first add 5 to both sides to undo subtraction. 5 cancels and you're left with 3 times absolute value y equals to 6. And then you can go ahead and divide both sides by 3. 3 cancels and your absolute value variable is left isolated. So our answer here is absolute value y equals to 2. And now that you have your solution, go ahead and state both of them by stating both the positive and negative values. So y will equal to 2 or y will equal to negative 2. Okay, let's go ahead and look at this one. So they're asking us to solve for y. It's similar to the very first problem that we looked at with absolute value, where you just have an absolute value variable set to a certain value. We can see here that absolute value y equals to negative 7. Now, right off the bat, when you see an absolute value set to a negative value, you can already state that there is no solution. The reason behind this is that we must recall that whenever you have an absolute value, whatever number that it equals to must become positive. It can never be negative. So you can't have a value within the absolute value coming out to be negative. It always has to be positive. So if you ever see an absolute value equation set to a negative, or you start simplifying and you see that it's beginning to set to a negative, you can assume that there is no solution. Okay, let's go ahead and look at a problem like this. We're given absolute value x minus 3 equals 2, and they're asking what values can be substituted for x to make the equation true. Now, to solve something like this, we're actually going to make 2 different equations set to the same given value and its opposite. This is because no matter whether the outcome is positive or negative, the absolute value will make it positive. So for now, we're going to disregard the absolute value brackets when we're setting them up. So when I say to set to the same given value and its opposite, I just mean to set x minus 3 to 2 and also set it to negative 2. These are the 2 equations that you're going to need to find the values. So you can go ahead and solve both of these equations as is to isolate your variable. So I'll just go ahead and carry out the standard inverse operations. Add 3 to both sides, 3 cancels, and you're left with x equals to 5. And then on the other equation set to negative 2, you'll also add 3 to both sides, 3 cancels, and x will equal to 1. So in this instance, the values that can be substituted for x to make the equation true would be 5 or 1. Let's go ahead and look at a similar one right here. We're given solve for x with absolute value x plus 3 equals 7. Once again, set up your 2 equations without the brackets. So I'll go ahead and set up x plus 3 to positive 7 and also x plus 3 to negative 7. Now that you have your two equations, you can go ahead and carry out your standard inverse operations with subtraction. So subtract 3 from both sides, you're left with x equals 4. And to the equation set to negative 7, if you subtract 3 from both sides, you get negative 10. So your x values would be 4 or negative 10. Okay, let's go ahead and solve an equation like this. We're given absolute value 2x minus 4 equals to 10. Now, whenever you see an equation like this where it's already set to a value, go ahead and create two different equations. So 2x minus 4 equals 10, and then another one to negative 10. This is the exact same thought process as the previous two problems that we've done. So now that you have your two standard equations, go ahead and solve them for your x value. First, I'm going to go ahead and add 4 to both sides. 4 cancels, and you're left with 2x equals to 14. And then divide both sides by 2. You're left with x equals 7. Do the same for the other equation. Add 4 to both sides. 4 cancels. You're left with 2x equals to negative 6. Divide both sides by 2, and you're left with x equals to negative 3. So those are your two solutions for this equation. Let's go ahead and do another one like that. We're given absolute value 2x minus 7 equals to 5. Once again, you're going to go ahead and create two equations, two standard equations set to both a positive and negative value. So 2x minus 7 equals to 5, and then 2x minus 7 equals to negative 5. Now that you have your two equations, disregarding the absolute value right here, you can go ahead and solve them. I'll go ahead and add 7 to both sides on this one. 7 cancels, and you're left with 2x equals to 12. Divide both sides by 2, and then you're left with x equals to 6, and that's your first solution. Let's go ahead and do the same for this one. Add 7 to both sides. Negative 5 plus 7 equals to 2. Bring down your remaining 2x, and then divide both sides by 2. You're given x equals 1. So that is your other solution. Okay, let's go ahead and look at this equation. We have negative 2 times absolute value 5x minus 3 equals to 12. Now we see here that we have a factor of negative 2 multiplied to the absolute value expression 5x minus 3. So let's go ahead and divide both sides first by negative 2 so that we can isolate our absolute value expression. Once we do that, we can see here that our absolute value is set to a negative number. So already we can tell that this will have no solution, because as we recall, that whenever we have an absolute value, whatever number that it equals to must become positive, and it can never be negative. So go ahead and say no solution. Okay, let's go ahead and look at this one. We have 3 times absolute value 2x plus 5 minus 7 equals to 11. First, go ahead and undo any addition or subtraction. I'll go ahead and add 7 to both sides. Now you have 3 times absolute value 2x plus 5 equals to 18. Divide both sides by 3 to isolate your absolute value expression right here. Once you do that, you have absolute value 2x plus 5 equals to 6. And now this looks exactly like the previous problems we've been doing, where we've been creating two equations that disregard the absolute value. So we have 2x plus 5 equals 6, and then 2x plus 5 equals to negative 6. And now you can go ahead and carry out your inverse operations. Subtract both sides by 5. that gives you 2x equals to 1. Then divide both sides by 2. And that gives you x equals to 1/2. Same goes for this equation. You have 2x equals to -11. Divide both sides by 2. And you're left with x equals to -11/2. Just a side note here, if you're looking at this absolute value and you've been thinking of it as parentheses, that is a good way of visualizing it. However, always note that you're not allowed to distribute any number into the expression within the absolute value. So for instance, you can't distribute the 3 to 2x plus 5 since it's contained within the absolute value. Just go ahead and divide it so that you can cancel it out and isolate your absolute value. Okay, let's go ahead and solve this one. We're given absolute value 2x minus 7 plus 5 equals to 12. So same exact steps. We're just going to go ahead and do inverse operations. First, subtracting both sides by 5. 5 cancels, and you're given absolute value 2x minus 7 equals to 7. And now that you see that you have an absolute value expression set to another value, we can go ahead and set up our two equations set to both the positive and negative value. So 2x minus 7 equals 7, then also 2x minus 7 equals to -7. Go ahead and carry out your inverse operations. Add 7 to both sides, and you're given 2x equals to 14. You divide both sides by 2, you get x equals 7. Same goes for the second one. Add 7 to both sides. You're given that 2x equals to 0. And once you divide both sides by 2, you get x equals 0. Okay, let's go ahead and look at a word problem. For a poem contest, the minimum length of a poem is 16 lines. The maximum length is 32 lines. Write an absolute value equation that has these minimum and maximum lengths as its solution. So we can identify that our minimum value is 16 and that our maximum value is 32. An equation that you have to remember for this particular word problem is absolute value x minus the halfway point of the minimum and maximum value will equal to the distance from the halfway point between both the minimum and maximum value. So that may seem a little confusing, but to help you, always use a number line to visualize your numbers. So I'll just go ahead and write a simple number line like this. Plot our minimum value, which as we identified earlier, is 16, and plot our maximum value, which is 32. Now you can go ahead and take the mean of these two values to find the halfway point. So to do that, you would just do 16 plus 32 divided by 2, and you would find out that it is 24. So 16 plus 32 would equal to 48, and 48 divided by 2 would equal to 24. So you would write that as your midpoint value. Now that you have your halfway point, you can go ahead and find the distance between the minimum value and the midway point, and then also the maximum value and the midway point. So you would find here that those would be equal. The distance between 16 and 24, you would just subtract it. 24 minus 16 would be 8. And the distance between 24 and 32, once again subtracted, would be 8. Now that you have both your halfway point and the distance from the halfway point, you can go ahead and set up this equation. So absolute value x minus your halfway point 24 will equal to your distance from your halfway point, which is 8. And if you were to solve this equation by creating two different standard equations, which would be x minus 24 equals 8 and x minus 24 equals to negative 8, you would find that your two solutions would be 16 and 32. Let's go ahead and do another problem very similar to the previous one. We're given that for a homework assignment, the minimum length of an essay is 2 pages. The maximum length is 6 pages. Write an absolute value equation that has these minimum and maximum lengths as its solutions. We'll go ahead and first make a number line to visualize our data. So I'll just go ahead and draw one right here, and then plot your minimum and maximum value. Your minimum is 2 and your maximum is 6. Go ahead and find your halfway point. Go ahead and do that by finding the mean. I'll just go ahead and add 2 plus 6 and divide that by 2. So 2 plus 6 will equal to 8. Divided by 2 will equal to 4. So your halfway point would be 4. Now that you've identified your halfway point, there is only one more step to be able to set up your equation. You're going to go ahead and find the distance from the halfway point between the minimum and the halfway point, and then the maximum and the halfway point. So the difference between 2 and 4 would just be 2, and then the difference between 4 and 6 will also be 2. So now you can set it up in your equation. Absolute value x minus your halfway point 4 will equal to your distance from the halfway point, which as we identified is 2. And there's your equation for you. Absolute value x minus 4 equals to 2, and that would be your solution. That is the end for today's lesson. If you would like to request a certain subject or concept that I haven't covered, please go ahead and navigate to the description box where you can find a Google form. Anything from pre-algebra to algebra 2 can be covered. If you do have any tutoring queries, I offer one-on-one tutoring services. And if you are interested, feel free to email or Google chat me at kaylin.david24@gmail.com. Thank you so much for watching, and I'll see you on the next tutorial. Bye.